All right, so this is what it looks like when you load SkySight for the first time. Today I'm looking at Australia, but you can see in the top corner here we have all the different regions we're forecasting for. So we've got South Africa, all of Europe, all of the US, even the Balkan regions of Europe, Argentina and Chile, New Zealand, Brazil, Japan, most of the places where people are flying gliders we have forecasts for. And we're always looking to expand as well. So if there's a local area where there's a lot of pilots that currently are underserved by other services, we're very interested, so get in touch. And if there's a group of 30 people, even in quite a large area, then that's enough for us to support some baseline forecasting services and get you going. So this is what it looks like when you log in. So the first chart it's going to show you is the hydrothermals. So we're looking at the hydrothermals all across Eastern Australia here. We got the scale up on the side here. If you don't like the units, I know paraglider pilots tend to prefer meters, so you just click and it changes the units for you. You want to go back to meters, change it back, and that's the same on just about all of the charts. So whether you want it in miles per hour, meters a second, or knots, centigrade or Fahrenheit, you can just click to change the units. So the first thing I look at is usually the potential flight distance in sailplanes. So this is showing us an estimation of how many kilometers we think you can fly based on a whole bunch of different factors, the strength of the thermals, where the clouds are, things like that. But that's probably a bit too broad of a parameter for paraglider pilots and hang glider pilots. So if you actually change your aircraft type up here, you see we've got different charts for paraglider pilots or hang glider pilots. You'll see we have things like a star rating instead. So the star rating, instead of potentially how far you can fly, it's how nice or easy the conditions are. So we're looking here for perhaps less than super strong thermals, so just moderate to medium strength thermals, not too strong winds, potentially some cumulus. And when all of the stars are aligning, you'll see it gets up to 5 stars, like areas here. And then when it's really not nice paragliding conditions, you'll see it goes clear here, which just means it's more or less unsoarable. You can see as you start to come in the coast here, we get up to 1 star, 2 stars, 3 stars, some areas of 4 stars, and then out to 5 stars in Central Australia.
That orange is the 5-star. I can't. The screen's not big enough for me to see. That's the you've got a horizontal. Yeah. Okay. Yep. Gotcha.
So you've got the scale over here to match up the colors as well. It's probably too small for you as well.
So is that kind of similar to in XC Skies, kind of the XC potential? You're basically looking at instability and cloud and
right.
Gotcha.
Yeah. I don't know how they calculate that, but I imagine it's a similar idea, that it's trying to show you how nice the conditions are for cross country rather than potentially how far you fly. I think that's another big difference between sailplanes and paragliders is the difference in what you can achieve differs so much more in paragliders with ability than it does in sailplanes. So even beginners in sailplanes can do 300 or 400 kilometer flights where experts are doing 500 or 600 kilometer flights. So a chart like potential flight distance makes more sense for us. Whereas I understand for paragliders, you have a lot of people who stay on the hill for their whole flying life. They just enjoy flying around locally. And then you have people who want to go out and do 300-400 kilometer downwind dashes and things like that.
Sure.
So that's why we've gone for the star rating for paragliders and hang gliders.
Oh, I love it. Great.
Another thing I like to look at then is do a point forecast for the site I'm flying from. So I usually fly from Kingaroy, which is right in here. And let's go back to different chart. And so we do a point forecast. We just click on this and then click where we want. And it's going to show through the day what the conditions are like in that area. So we can see 16th February, that's today. It gives us a little chart of the convection through the day. So we can see thermals are starting very early at 9:30. We're getting to 2,300 feet above ground, which is about 4,000 feet above sea level. We can see it's quite breezy. We're seeing 14 knots on the surface and 23 knots at the BL top. People ask what the BL top is. That's the top of the boundary layer, which is where the thermals go to. So that's the max height they go to. I've tried to get rid of this term boundary layer because I know it's a bit scientific and people don't necessarily know what it means. But if I say top of thermals instead, well, that's not really true when the thermals are very weak and the boundary layer can actually be much higher than that. We got the temperature as well, and we got a little pictorial representation. So I get questions asking, well, how many octaves is that? So the idea is we're trying to represent things how pilots see them when they go outside. So when you see it like this, well, we're hoping that's sort of what you're going to see when you go outside. So small Q with a bit of a dark backdrop, and you can see backdrop getting thicker and thicker here. So some stratus around, some overdevelopment. And we can see above up to the high cloud and the mid cloud, nice clear skies. On this same chart, we give you the 3-day outlook. So you can see tomorrow, we can see not so good. We got some high cloud. The day dies off much earlier. You see the thermal strength's much weaker there. And if you look very closely, I probably won't be able to see it in this recording. You can actually see that little cumulus is raining there.
Oh yeah.
Same later in the day as well.
Thermal strength there. Okay, so explain that, how you have that configured.
So thermal strength is roughly what we expect you'll see on your instruments. So we've already minused out the sync rate for you. It's what we think the average thermal will be if you're flying at that point in time. So I'm sure a good pilot will be able to find a stronger thermal if they hunt around or find a good trigger, and a beginner pilot might find a weaker. We think that's going to be about the average.
Geez, 16th looks good.
Yeah, it's a nice day today.
Yeah, very nice day. I shouldn't have you doing this. You should be out flying. Looks great.
Got a week's flying coming up next week, going to a competition down in Lake Keepit, so I'll survive.
Nice.
So after I've looked at that, depending on what I'm planning to achieve for the day, I'll start looking at other charts. So for us in sailplanes, the cumulus is very important to us. So I'll have a look at the Q cloud base chart. So this is showing us for areas where it thinks there will be cumulus, what the cloud base is going to be. So we can see if we zoom right out, we can see out this whole area here is blue. And then out here, we're getting to about 8,000 feet. Out here, we're getting to about 10,000 feet. And out on the coast over the water to about 2,500 feet. So you can see how that steps up. And then there's this gray area here, which can be a little bit confusing. And that's showing areas where there's a lot of uncertainty as to whether there's going to be cumulus or not. So if there is going to be cumulus, they're probably going to be very small. Maybe if there's a fire or some really good triggers, or the forecast is wrong a little bit, they'll be much bigger or smaller. But we're really not sure if there's going to be cumulus there at that point in time. So we try and represent a little bit of uncertainty in the model where we can.
Okay.
The next thing to look at, particularly if you're flying just within this area here, is the cumulus depth. So we can see a representation of how big those cumulus are going to be. So this, when I say depth, that is from the top of the cumulus to the bottom of the cumulus, how big is it? So here we're seeing about 1,000-foot tall cumulus. When we go out here, it's still 1,000-foot tall, but then you see quite quickly we get into these bluer colors here, where it's potentially even representing negative. So when it says it's negative 1,000-foot tall, what it actually means is if the thermal went 2,000 foot higher, it'd form cumulus. But at the current height, it won't. So if we change back to the Q cloud base, you'll see this area is blue. But if the thermals were much stronger than expected here, it could form cumulus. So that lets you sort of gauge the potential for the forecast to not be right. So if you're setting a task and maybe you're flying a really big task and you're just forced to go out in an area where there isn't going to be cumulus, you can at least target the areas where there's the best potential for there to be cumulus if the forecast isn't right. So maybe we'd set a task that had a turn point out this area here rather than out this area here where there will be no cumulus when you see it clear like that. It's way too dry. Whereas in here, well, there's a possibility. It could still happen. The thermals only need to be 500 foot, 1,000 foot higher.
But could it be blue and still working there as we go left, or is it just too stable?
Yep. So we have a chart, just the height of thermals, which will show us how high the thermals will be, and that's regardless of the cumulus. So we can see out here we're still seeing those 7,000 feet, and out here we can see it's only going to 5,000 feet out here, which is probably why it's not forming cumulus out here.
Gotcha.
We can also look at the thermal strength, and we can plan our task in the areas that are going to have strong climbs. So we can see the yellow here is better thermal conditions than the green, and out here I think it's saying it's going to storm up quite badly or overdevelop. And same along the coast here, you can see very broken, patchy conditions.
So is yellow kind of the sweet spot?
If you can get red or orange, that'd be even better. So we see a bit of orange down here. It's probably coming from a convergence line, which we can look at a bit later. But you also see these stipples, so this dot pattern. And this dot pattern is representing how broken the thermals are. So when you see these faint, broader dots here, that's indicating mildly broken thermals, and when you see these bigger, thicker dots out here, that's indicating very broken thermals. So that's just calculated from the ratio of the wind speed to the thermal strength.
Okay. Yep. So that's the brokenness is because that your buoyancy isn't strong enough, correct?
Exactly. So it's
Okay.
literally the buoyancy shear ratio, the ratio of the
Yeah.
thermal strength to the wind shear, or people like to call it the bullshit ratio, so how bullshit the day will be. Sorry for the kids watching. Some people also, there's a chart that some people like called the significant weather chart, which tries to show on top of the hydrothermals a little pictorial representation of what's going on. So we had that Q cloud-based chart before that showed us where there was going to be cumulus, and you can see that same information is presented here. So we have nice sunny blue conditions out here. You can see conditions with big cumulus out here, small cumulus here, and you can see areas of overdevelopment where the Q are getting big and dark all through this area here. And you'll see this.
So the big and dark ones, would those be, would those be like thunderheads?
And probably not thunderheads, just spread out, underclag in, weaker
Okay.
thermals. Where you get thunderheads, we have this little one here where it goes red, and you see a little lightning symbol underneath.
Oh, okay.
So that's
Gotcha.
the potential for thunderstorms, for QNIMs, that kind of thing. And you
Okay.
see also some of them have that little wind sign on top, which is indicating it's very windy in that area, stronger than I think 16 knots or something.
Hmm.
So we try and
And
have that.
does that change whether depending on if you've got it in the paragliding mode or the sailplane mode or the hang gliding mode?
This one does not.
Okay.
So it shows just the same information for everyone. It could be something we add that we make the windy symbol appear earlier for the paragliders. So 15 knots is probably getting a bit much for you, whereas for us it's not such a concern.
Sure.
There's a couple more icons around that I can't seem to find. Here we go. So you see where it's got the little bar across the top. That's trying to show you there's some high cloud above the conditions. When it's got the dot, it means there's no thermals, there's nothing. Nil significant weather. And there's a little rain one as well in blue, but there's not much rain in Australia today. Moving on, we talked about overdevelopment. We have the overdevelopment chart, which is showing us again that potential for spread out, sort of too much moisture just at the top of thermals there, really ruining the conditions. And you can see out here, it's really quite extreme. So I've got a very arbitrary unit here. So the unit isn't really a unit of anything. We've just tried to put together a number of parameters. It's really challenging because everyone has a different idea of what overdevelopment is. So when I said it before, you said, oh, so you mean thunderstorms. So in this case, I've tried to do just sort of excess moisture in the boundary layer. So things that are going to mess up your day from too much moisture. So it's causing spread out, potentially developing in thunderstorms, but we try and represent thunderstorms by themselves differently. So we can see all through this area here where it's really red, probably too overdeveloped to have a good flight. Where it's out here in the green, it's going to be a factor, but it shouldn't ruin your day. And when it's out here, this kind of color, that's kind of ideal conditions. So it's starting to get big Q, nice cloud suck, that kind of thing going, but not overwhelming, not shading out too much of the ground. So often pilots who are flying in sailplanes at least will sort of be targeting the edge of this area here as the best conditions for them. And with caution going deep into these kinds of areas here where it could be too overdeveloped. But I think these kind of conditions are still fine to fly, and it's only when you get to the red when I'd be concerned.
And Matt, I can't see what it is, but is that bar with the blue right above your map? Is that the time of the day? So
That's
you
right.
can advance this back and forth. Okay, gotcha.
I should have shown that before.
Right
So
there.
we forecast
Okay.
from 8 a.m. to 8 p.m. in all our regions, sometimes a little bit earlier or later. You can move it through any of those times. You can change your time zone. And over here we have the date, so you can go forward a day, back a day.
Gotcha.
We also have this little play button here, and you can click that at any time, and it'll just animate the forecast through for the day and show you how the conditions are changing. I find that's really helpful to sort of understand how the day is progressing, to just click play and watch that.
Yeah, that's
Particularly
terrific.
something like hydrothermals, you can watch the day start. So for thunderstorms, we have an explicit chart itself, the CAPE or storms parameter, and this is actually showing you if there are thunderstorms, how powerful they're likely to be. So it's showing how much energy is getting released when those QNIMs start forming. And you can see today, okay, there was some potential for thunderstorms, but at least in this area here, they're going to be very slow growing. There's not a lot of energy coming into them. So the potential for them to be damaging or dangerous or to suck you up in them is really quite low. But when we go way up into North Queensland, you can see this is really quite high out here. So when you get into these greens and getting into the yellows or reds even, those thunderstorms can form very, very quickly and be a serious risk to your health. But fortunately today down here, not such a problem.
Matt, how have you handled CAPE in various different regions? This is something that I've really only tapped into in the last few years. But say for example, in the Rockies where it's high and desert and really high bases, very thin air, if we have any CAPE at all, it's like down at the lowest level. If it's showing CAPE, it usually means it's going to OD. And if there's any kind of even low to medium CAPE, it's just you don't touch it. Whereas in other parts of the world, that's totally fine. It's like as you get closer to the tropics, you don't even worry about it.
Is that your experience on SkySight or in general?
No, that's my experience on XC Skies.
Okay. So I don't know how SkySight calculates it, but it is a really difficult thing to calculate in an independent way and also to calculate efficiently. So a lot of people put a cap at around 700 millibars in the atmosphere high, where they start to cut off a lot of the calculations. And when you have a really high terrain level, those calculations won't work anymore. They will give you grossly different values. If you look between different providers, calculating CAPE, even from the same data source, like starting with the exact same data set, you can come to wildly different numbers because there's just so many different ways to calculate it. So we used to have that problem in South Africa where the CAPE numbers just didn't seem to make sense representative to the risk. So at least I think SkySight doesn't suffer from that problem, but I would welcome more feedback on that if you're seeing the same thing in your area.
Cool. I'll keep an eye on that.
Looking at a couple more things, so cloud cover, of course. So cloud cover is showing us areas of low-level cloud in blue, mid-level cloud in green, and high-level cloud in red, and it tries to do that all on one chart overlaid on each other. So we can see areas of blue, so cumulus, stratus, anything that's thick forming in that area. Shallow cumulus fields won't really show up on this chart. It's really just looking for stratus and kind of layers like that, or potential strong overdevelopment. You can see the mid-level cloud there as well. So up near Townsville, some alto Q, something like that. And then the red there is the upper level cloud, so things cirrus.
That's terrific how you've meshed that all together. That's quite nice.
Every chart has a little help box down the bottom here, which explains what you're actually seeing. So you see here it explains that low means 0 to 4,000 meters, medium means 4,000 to 8,000 meters, high means 8,000 meters plus.
Okay.
For the wind, of course, the wind is super important for you guys, so we've got that in as much detail as we possibly can. We've got a choice between having the wind barbs like that, or you can have the wind streams if you like the windy style presentation. You see the little streams start to fill in. And we show all of this, the full resolution of our weather model. So the streams actually, if you keep zooming all the way into little tiny mountainous areas, you'll actually see how they follow the valleys and things like that. We're not doing any interpolation or anything to draw these charts.
How often does it update? That's always something I've gotten kind of confused by. If you're in GFS, you get it every 4 hours. If you're in ECM WF, you can get it every hour. But you said you're kind of compiling it all into your own system. Is it every hour? Is it 3 times a day? How does that work?
Yeah, so we update today's forecast. We try and have an update ready at 8 a.m. regardless of all other factors. So we use the most recent initialization data set before that, and then we update it with all the latest information we can get together, and we try and have that forecast ready at 8 a.m. In whatever region you're in, whatever time zone you're in. And then we have another update for tomorrow's forecast at around 5 p.m. for every region. So they're the only 2 times that we're trying to actually commit to that there's going to be an update ready and waiting under any circumstances. Other than that, we try and do roughly 2 updates a day for days beyond that, all the way out to the end of our forecast range. So we forecast for about 6 days of forecasting.
Cool.
Beyond that, it's not really giving you any useful information.
Would you be able to use now that you're in the wind section here with the strands? Is that what you're calling it, strands?
Streams.
Streams.
The term we came up.
Is that something you could use for potentially identifying a convergence line?
Absolutely, yeah. So we do have the convergence chart by itself, actually, which is just showing us. So this is only really possible because of the resolution of our models. So that we're able to really resolve these sea breeze convergences. So this is actually where I come from, Adelaide. You can see we have very reliable sea breeze convergences all the time. So we're picking up, you see how weak these convergences are that we're picking up. This one, it's only peaking at about 1.5 knots, but it's such a long convergence, you can have great flights along this line here. And you can definitely see them on the surface wind chart. So if we put that back on, you'll see that line of weaker wind there where it's just converging from 2 directions. I think the barbs actually shows it better than the streams. So you can see you've got the southwesterly here and the northeasterly here converging on this line here. I think you'd do a great day flying along there.
Yeah, wow, cool. Neat.
And this is, yeah, a key difference, I think, with our product than a lot of other services, particularly outside of regions like the US where you've got models like the HRRR model, which can resolve convergences, but outside of the US, no one else has the benefit of that. And there's things like GFS just won't resolve the sea breezes. They don't understand what's happening. So by planning your flights along here, you can get a real good advantage. So you see a huge convergence line along here. I've long dreamed about doing a big triangle along this area
Yeah, no
here.
kidding. Wouldn't that be cool?
Or you could do a 1,000-kilometer triangle, I think, through this area here, utilizing convergences for 500 or 600 kilometers of their flight. Which is a nice segue to the route forecast. So the route forecast lets us draw a task on the map and get a cross section of the weather across that task. So if we click here and here, it'll show us what the weather is like through that region. So in this case, it's blue. You see the red line is the soarable height, about 6,000 feet. You see the black line, which is actually the top of thermals, so where the thermals are getting to that we think you won't be able to get to, a little bit higher at 8,000 or 9,000 feet. And right up at the top there, you can see the condensation layer.
And do you put times? Oh, that's over on the right hand side. Yeah, okay. So you could kind of designate when you're going to start.
That's right. So unfortunately, it's not very good soaring conditions actually out there today. So it's not a great example to use. It doesn't look that bad actually. But let's go back out to New South Wales where it's a bit better at the moment. So we can draw a little task and it'll suggest an optimal start time, an optimal finish time. So we can see, if we zoom right in, we can see it's drawn a black line for us, which is what it thinks the optimal route around this task will be. So if the conditions are better one side of track than the other, it'll suggest that. So it thinks going a little bit to the south of track here is better. And then it suggests over here, the different times a day, if you start then, what speed you'll do. So if we start this task at 3 p.m., we'll do 140 kph in 47 minutes. That's obviously way too fast for a paraglider, which is why if we change to paraglider mode, it'll give us greatly different speeds. So I might have to reduce the task a little bit here. Something not working there. I love doing live demos.
Sorry, man, we can edit.
Yeah, so if you do this again with a paraglider, you should see wildly reduced speeds. So it'll show you 30 kph instead of 150 kph there. What you can also do is do a live suggestion. So we can go click here and then go, I'd like a short out and return task, please. And it's going to calculate from this point what it thinks the best task for you is. So here it's suggested a 280 kilometer task.
Crazy. That would be so cool in the, these out and back hike and fly races that are becoming so popular in Europe. You have to pick it. You usually got, 36 hours or 48 hours, and whoever wins goes the farthest out and makes it back.
Yeah.
And so the big part of the game is which way to go, to start off with and to hike the least and fly the most. So this would be great.
Yep. It's super useful. And it'll even consider things like airspace. So if you turn on the airspace layer, it'll consider that you can't fly in Class C airspace and things like that in that calculation. And then it won't suggest a route through that airspace. It'll also do straight out tasks, and I think his name's escaping me, but the British guy that set the paragliding world straight out distance record in Brazil a couple of years ago, maybe 2 years ago, Henry.
Yeah, Guy Anderson. Yeah.
But their team was using SkySight and used the route suggester for their straight out distance flight. So you can choose a straight out task and it'll suggest which direction is going to be the best straight out for you. And that's considering thermal strength, it's considering the wind. So on a straight out task, it'll consider the best downwind route for you if possible. And when you're doing triangles, it'll suggest the optimal way to fly around the triangle for that wind. So we try and consider as much as possible in that.
Wow, very cool.
Switch on that airspace layer and you'll see, hopefully, with the airspace, if we click a route around this little, if we click a route across this airspace here, you can see how it understands you can't fly through that CTR there, and it suggests an optimal track that goes around it. We do have the option here to toggle between point to point and optimized. So when you're doing point to point, you see this cross section shows you the direct route across, but you might actually be more interested in seeing the optimal route, and then it shows you a different chart which is showing you going around here, and you see now the pointer follows around as we move the mouse across here. And if we really want to show off, we can do a little 3D view of our flight as well. So it probably doesn't make sense for the task of this length, but if we click play here, it'll actually take us in and fly us around the task and show how the conditions change as we fly through here. So if you want to get a picture of what you're expecting the weather to look like around your task as you actually are flying it, it's nice to just give you a little insight of what it's going to look like to the left and right of you as you look out the window of your glider.
How did you make that happen? What are you pressing here to make that
You
go?
just click the play button up here, the same one we used before.
Oh, okay. Yep, gotcha. Oh, wow, cool. Very nice.
On a lot of charts, if you press the play button, if there's anything extra to show you, it'll
kind of take you through it.
Yeah. All right. Let's see what else we have. So another chart. So this is a chart I built explicitly at the request of quite a few paraglider pilots. Sailplane pilots don't seem to find it so useful. It's the point windgram. So actually, let me first lead with a skew-T. So are you familiar with how to read skew-Ts?
Yep. Yeah, roughly. That's always been one of my Achilles heels.
It seems to be within the paragliding community, skew-Ts just aren't part of the flying training, whereas within sailplanes, we learn them right from day one. So for sailplanes, we like to read information about the vertical atmosphere from a skew-T. And I think the reason that paraglider pilots like the windgram is it's actually showing you the same information, just in a much easier to interpret and actually more useful way. This one takes a little while to generate. So this is showing us, for this point, what's happening in the atmosphere above us through the day. So we see, here we're looking at the lapse rate. That is the stability of the atmosphere. So we can see that through the day, there's this stable layer above us at about 3,000 feet that slowly lifts higher and higher. So this unstable layer here is where we'll be flying. We can also look at the humidity through the day. So we can see as well, we can see all this humidity up at 3,000 feet, and you can see how that lifts through the day. And that's where those clouds are going to be that we saw on that map before. So it's really nice to show how the day is going to change. And if there's going to be a front coming through or something like that, you can really see these dramatic changes coming through at about 2 or 3 in the afternoon when the front comes through, and you see a big, it looks wrong actually when you see like one chart that looks completely different to the other as the air mass above you totally gets replaced. So I find that really useful for understanding what's happening through the day, why something is changing. So again, here we see with the wind speed, we can see strong winds in the morning, then light through the whole day, right until the evening, and that's probably the sea breeze coming through there with almost 20 or 30 knots later in the day.
Oh, that's terrific. Kind of looks like the RAST.
So I think we're getting near the end of the charts we got. We've shown you all of these ones. If I know paraglider pilots are very rarely flying the wave, but it is possible. So if there's wave conditions, that is mountain wave or potentially thermal wave, it'll show up on here. So not really any wave in this area today. If we jump across to New Zealand, I bet there'll be wave though. No? Oh, there's a little bit of wave up here. So probably some wave or even ridge effect off the central coast there. Maybe Argentina is a better option today. No, it's not a very wavy air mass just at the moment.
Summer down there, right?
Yeah, they do get very good wave in summer though. So you see
Oh, they do. Okay.
tomorrow. Yeah, there's some nice waves. So you can see the classic wave patterns. We can see that in 3D as well, which is also just showing off, I think.
Show off. That's good.
This one takes quite a while to load in Australian internet.
Are those circles airspace?
That's right. We've still got the airspace layer on. So here you can see the wave actually in 3 dimensions, but it's quite broken today. So this is showing within the air mass where it thinks the strongest wave is, as little blobs there.
So when that's really good, will that just be a complete line of those?
That's what you want to see. Yeah, you see here it's super chaotic, so it's not really joining up well at all. It'll be much nicer to see a straight line. I guess another thing very useful to paragliders would be the ridge. So predicting ridge soaring conditions is actually really hard because the ridges most people fly on are so small that even at the detailer model we're trying to run, they're still barely resolvable. But we pick up quite a lot of the medium-sized ridges, let's say. So I actually downloaded a flight before off the OLC, that's our X-contest, of some guys flying in South Africa. And I can just click upload there and it will pull their flight off, it'll upload their flight and show the track on the map. And you can actually see their flight along this little ridge line here. If we go to the ridge lift chart, this will try and show us, yeah, there you see them flying along this ridge system here.
Oh, wow.
So you can see their track line there, just staying along the best part of the lift there. And you can see how well it matches up to where the ridge actually is. Although the model seems to think the lift is a little bit further upwind than they're flying, but I think that's just the detail of the model that in reality, of course, the lift is a little bit closer to the ridge than the model thinks it'll be. But yeah, I think they flew 1,000 kilometers going up and down this ridge over and over.
Really? Yeah. Wow, cool.
And you'll see it color codes the track. If you initially it'll color code it based on altitude, but if you are looking at a chart like ridge lift, when you upload it, it'll color code it according to the scale here. So you can actually see how strong it is according to or compared to the ridge lift you're looking at as well. For wave, we do a little cross section across the wave that can be interesting to show as well. For general flying, so we just click on one point, another point, and this just gives us a slice through the atmosphere along that point, and then lets us have a look at that. So here we have that little tiny ridge. You see ridge lift associated with it there. That works really well on convergences as well. If we go back to East Australia, I do apologize for jumping around a bit here.
No problem. This is great.
If we look in at this convergence line, we can actually get a sense of, well, what's the shape of this convergence line? So a problem I often have is there'll be a convergence line forecast and I'll get there and it's just not as strong as I expected looking at this chart. And what I think I've figured out is that it is actually strong, just not at the altitude I want to fly it at. So some convergences seem to be really strong right at the surface level, at the lower layer, and some actually carry that strength all the way up. But with the wave cross section, you can actually see a slice through here. So here we can see actually this convergence is really quite low level. So we're up at 4,000 feet here, and above that there's not really anything more. It's really only happening just down near the surface there. Whereas some days you'll see this massive red O shape going all the way up to 4,000 meters or something, and that's when you know it's a better convergence for actually flying along. So perhaps today wasn't the day for a record flight.
Okay.
Another thing worth noting is that route suggester and optimizer considers convergences as well. So whether or not it likes this one, I can't say, but in theory, it'll tell it to follow along there, but maybe because it's so low level, it's not going to like it. It thinks this task isn't achievable anyway. Actually, Yeah, so you can see, yeah, it does actually follow it. So of course, because the convergence moves through the day, we can see as we move the slider across, it's suggesting to go down this convergence line here. And then it jumps across as it curves around and back on it again over here.
Geez, that's some fancy computing you guys have done.
Yeah. So when you think of all
Impressive.
the convergences in the Alps or the mountains where you fly, hopefully it'll try and do the same thing. I think I would like to talk a little bit more about actually interpreting it in the mountains though. So a lot of the wave, oh goodness, look at the wave there. So I think that's very strong wave conditions you got out in the west coast of the US today.
Yeah, it's really howling. That makes sense.
Mm.
Boy, that'd be cold.
I think it still will help us read this a little bit. So one of the challenges is when it's in the flatlands, when you're trying to show something like cumulus, it's easier. We just show, well, this whole area will have cumulus. But I mean, we know that it actually won't be. Like cumulus don't fill the entire sky. There's gaps between cumulus. But when we get to the mountains, it's very difficult for us to then express where the cumulus is going to be, because the model has enough detail that it understands that the cumulus only come from the peaks. So you start to get these gaps forming here. So you see there's Q forming along this hilltop here and Q forming along here, and there's gap in the valley here. And people read this and they think, oh, okay, so there's not going to be very much Q, or it's going to be not very good Q conditions, because when I fly in the flatlands, we're looking for it to look like this, and here it doesn't look like that. So that's a bit of a flaw in the website, really, that I haven't found a good way to fix, is that as we make the detail get higher and higher, when you're flying in the mountains, it's showing ever thinner lines of Q, because it understands where the Q are coming from and that they're not coming from the valleys, and it looks every time that we increase the resolution like there's less and less Q in the area there. So I need to work on a better way to represent that. But that's a real gotcha for people flying in the mountains, is that when you see those big spacing between the Q or areas of potential Q like that, it doesn't necessarily mean it's bad flying conditions. And the same caveat applies. So today there isn't really any thermals in there because it's 40 knots of wind. The same caveat applies to the thermals, that it understands that the thermal strengths, or the thermals, are only coming from the peaks, and that's where the thermal strength chart will show the strongest thermals, just following those little hilltop lines there. Fortunately, I don't have a better example.
How did you pick out that it was 40 knots just like that? Was that a color that you're just used to seeing, or was there something up that I didn't see?
That was just my guess from the strength of that wave.
Oh, okay, gotcha,
If we jump
gotcha.
back to this chart here,
Oh, there we go. There they
yeah,
are. Yep.
and
Okay.
howling. One more thing I've omitted is the sat view. So if you want to see a satellite picture, we have satellite pictures from every provider, and we've gone to really a lot of effort to get absolutely no quality lost between the provider of the satellite picture and having it on your screen here, because we want to show you what there really is. So seeing individual cumulus and things like that. And that's really actually been a challenge to do, to get the original data source and not lose any fidelity through the process. But it really pays off. So here you can see some mid-level cloud, and you can actually see the shadows from that mid-level cloud on the ground underneath. We
That's
can
terrific.
see some little cumulus streets, or maybe even some wave influence. So just from the easterly pushing through there, we can see
And is
here.
this something you can hit play on as well?
That's a good question. In theory, yes, but I think my internet will not be fast enough to support
Right. Yeah, I gotcha.
loading all the tiles in advance. Yeah.
There you go.
If
Yeah,
you
it works. Yeah.
if you let it sit through a full lap, it'll load all the tiles and then come through better the second
Right.
time.
Right. Gotcha. That's handy. Yeah, great.
And we have an amazing satellite in Australia, amazing satellite in the US, and a quite good satellite in Europe. Europe doesn't. It's only got one high resolution satellite, and it's about a quarter of the resolution of the one we have in Australia, remarkably. But I look at these in flight, so we integrate with a bunch of devices. I know you guys don't have LX9000s, but that's the top of the line device we have, which shows you the picture of this in flight. But you can still use this on your phone. So the whole website is designed to be user friendly on both a phone or an iPad or whatever device you have. We can see what it looks like on a phone here. This is what you see on your phone, and then instead of having everything down the side, it's just a little click here to turn it on, but you can see the satellite picture. And I don't know what this will do on my computer, but if you click here on your phone, it'll put a little dot, there you go, where you are. And that dot will move around as you're flying. So you can actually see where you are in relation to the forecast and how everything looks around you.
Wow, cool. So if you have cell service when you're flying, you can pull all this up.
Absolutely.
Hmm.
So that's super powerful. You can also install the website. So if you just click on the little settings of your browser and go add to home screen, that then gives the website permission to store data on your phone, and it'll show little icons here that let you download the day's forecast onto your device. So even if you don't have cell service, you can still look at the forecast convergences and all that on your device and see where you are in relation to them. Maybe you're a bit off too much to one side than the other. It's really cool to be able to fly convergences in the blue with no cumulus at all. So, I mean, they're happening all the time, and usually we can't exploit them because they're just too hard to follow. But if you have a map of where they're going to be, then it makes it a lot easier.
Show me again how you would download that to your phone. I missed how you do that.
So I can't demonstrate it on the computer. You
Oh,
have to
okay.
go on the
You have
phone,
to, you have it
but
on the phone. Okay,
you'll be clicking on the top right or something. It'll say something like add to home screen or install or something like that.
okay,
It's a
gotcha.
function of your browser actually, not of the website.
Oh,
So
okay,
you've got to look for the add to home screen setting. It works on iPhones and Androids. It is a little bit hard for us to control though, because some phones set like storage limits and stuff like that. So it only lets you
sure.
download one chart and it doesn't tell you it's hit its limit. So it's a little
Hmm.
bit tricky, but it does work quite well.
Hmm.
Um,
Fascinating, amazing.
if you want to upload your waypoints, you can upload any cup file you like, and it'll put little dots on the map where all your turn points are. So you can see I've just uploaded and it's labeled all of our turn points here. So it's 052 Garima, 027 Bircher. So if your competition gives you a waypoint file, it's really useful for planning your task. And when you're doing the route planning, it'll snap to all of those turn points to give you the exact task around those turn points. Currently, we load actual competitions, real-time competitions going on from Soaring spot. I know that's not super popular with paragliders, but there doesn't seem to be any central database of your competition tasks for us to pull from. But if that ever does happen, we'll be sure to start loading tasks from paragliding competitions as well. So that's today's task at Narromine today, drawn for you on
Hmm.
the map.
Oh, cool.
So
Very neat.
I think that's all I've got. So if you've got any questions, I'm all
No,
ears.
I just can't wait to play around a little bit more. This is a great overview. Let me just ask you, Matt, when you first sit down in the morning and pull this up for, say, it sounds like you're going on a flying, to a comp this next week. Take me just very quickly through your workflow. What's A,
Sure.
B, C, D? How would you attack the day?
Yeah, I did start with that, didn't I? But then I got distracted. So if I was flying at Narromine today, where this competition is, so first I look at the potential flight distance. That gives me a quick check. Are we going flying today or we're not? So today looks like we can do 500 kilometers, but if we were out at Blackheath, I wouldn't get out of bed. Um, then the next thing I look at is the point forecast, and I click at Narromine, and that's going to show me when the thermal is going to start, and then I know when I got to have the glider ready by. So we see good thermals from, so for sailplanes, less than 3 knots is pretty hard work. So I'd be on the grid, I think, at about 11 o'clock, ready for takeoff.
Okay.
And then I'd be looking at the end of the day, so I can see, okay, there's no thermals at 6:30. I got to be home at 6:30 or on glide by 6:30 from somewhere nearby. So even at 5:30, I can see it's super weak now. So actually, I think I'd like to be on glide by 5 o'clock this day. So now we've got our little window to plan a task in. So a 500k between about 11 and 5 o'clock. For sailplanes, we like to look at the XC speed chart, which sort of lets us see over a large area where there's fast and slow conditions. It's a little bit harder for me to do that for paragliders, but I'd be looking at the star rating, I think, and trying to plan a task within the good area here. So we can see at Narromine, okay, it looks like it's nicer out in this area to the southwest. So I'd be setting a task out in that direction. So maybe I'll look at the Q cloud base as well for development. A quick check of the significant weather to check that we haven't missed anything like some rain showers in the afternoon, or maybe there's something else going on in the task area that wasn't affecting around Narromine. Doesn't look like there's too much going on other than being quite windy. So then I think I'd be ready to plan a task, and I'd go from Narromine. If I wanted to suggest a task, I could just suggest one, but if it's a competition, they've probably given you one anyway, so I can draw out the task and Have a look at what it looks like. And then we can see our cross-section of the weather through the day. We can see if we want to start a little bit later than that 11 o'clock, maybe we launch at 11 o'clock, but we don't start the task till 12:30. Have a look at the route it's suggesting for that time. And I think that's all you really need to see to get an overview of the weather for a day.
Something I learned, well, I don't want to disrupt your flow here. Keep going and I'll ask you another question.
No, I mean, I think that's all I'd really
That's
look
pretty
at
much it.
for a basic
Okay.
day. For paragliders, I guess you'd want to consider the wind a lot more. So have a look at the wind charts. We can see the very strong easterly flow there. Have a quick check at overdevelopment in the area. Not too bad. Have a look at the Cape. Okay, not a significant factor. A little bit of high cloud coming through later in the day, but really very slight. I think that's all the things I'd look at. And then I'd start just watching the satellite picture and seeing if it's unfolding as forecast. You can click on the webcam layer as well, which will show us little pictures from all the areas around, and we can see if it's looking like it's meant to be looking. So we can see a Dubbo little picture of nice cumulus there already. Out here, there's not so many cameras in Australia, but there's a lot more in the US.
Yeah, that's great. That's super handy.
It's great in the Alps as well in Europe. You can see they got loads
Yeah,
of
there's so
cameras
many
everywhere.
there too. They're top of every ski area.
And yeah, I think that'd be all I'd really need to look at to go flying for the day.
One thing that's been more and more, and I know was a big factor for you guys last year with all the fires, but here in the West, we're dealing with a lot of times we're dealing with stuff in our atmosphere that really slows things down, namely smoke. But I can think of, in the last X Alps, we had this crazy high pressure that came in from Africa, and that's often associated when it gets those big, strong southerlies from Africa with a lot of dust in
Yeah.
the atmosphere, which isn't something that a lot of sites pick up. Is there a way to show that in SkySight?
So no one is really modeling dust at production scale weather model, I'm afraid. There's a couple of experimental models, but it's not really there yet. There's a little bit factored in, but it's all using like climatological databases. So they just go, oh, well, this part's a bit dustier this time of year. So in terms of dust events, not really much I can help you with there. For smoke, though, so within the US, there is a special model running. It's just an experimental model at the moment that actually calculates the effect of smoke on radiation, on everything. So we've actually integrated that with the HRRR option. So when you're in the US, you have not only the SkySight weather model, but we do also give you the option of HRRR. So a lot of people like it. They've used it on Axios Skies or used it somewhere else. They're not interested in our forecast. They just want our user interface and someone else's model, which is fine by me. I'm happy to facilitate. So we have the HRRR model, all of the same charts as before, but one of the charts is the smoke. So I don't think there's many fires going on in the US just at the moment.
Nice and cold.
But when there is, it'll show you areas of smoke, and the thermal strength charts and the Q cloud-based charts, everything will then be considering the effect of smoke. And I think we're the only people who have tried to do that for thermal conditions so far. And by all reports that I had earlier this year, or earlier last year, it seems to actually work fairly well. So it's calculating the impact of those big smoke fires in California quite well.
Fantastic. Yeah, great. Yeah, we had a dust event. We were down in Texas trying to break the world record last summer, and we had a dust event come across from Africa that was just unbelievable. It was incredible. And they forecasted it really well, but we really had no idea what it was going to do to us. And it was interesting.
It's still a big question.
Matt, this is terrific. I really appreciate it, and I know our listeners will as well. Thanks so much for sharing this, and thanks for doing this. Thanks for making this happen. What a valuable, wonderful tool.
I was super glad to be here. Good luck in the X Alps. I'll be watching closely. I think there's
Yeah,
quite a
now
few
that you're a
pilots using
paraglider,
SkySight this
that'll be
year.
fun to watch.
Yeah.
Great. Well, yes, this will be incorporated into the race for sure. Revis uses it all the time. He's my weather guru. So thanks very much, Matt. Appreciate it.
Thanks for having me.